Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's webinar is Database as a Service, Cloud Computing. Our guest speaker today is Om Prakash Daltandani, Database Star Lead at one of the leading IT company. Om Prakash is a certified DBA and Linux Unix administrator with 22 years cross-platform experience as core Oracle DBA, developer, architect, Sybase, DBA and SQL DB expert. He has worked as senior DBA project manager, senior consultant for a top international bank, SFI and MNCs. Om has worked as a team leader for large DB teams. He has led several migration projects for critical databases requiring 24/7 by 365 support. Om Prakash has authored several articles and blogs on the database topics covering replication, migration, standby databases, data guard, and updatable snapshots and MVs. So without further delay, I introduce you all to our guest speaker, Mr. Om Prakash. Over to you, Mr. Prakash.
Thank you. So good afternoon, everyone. I am Om Prakash, and today we will discuss about database as a service, cloud computing. So I presume I am audible as well as visible to everyone. And with this, I would like to proceed straight away with the agenda for today's webinar session, Database as a Service under Cloud Computing. The agenda for today's webinar would be as follows. We will start with an intro on cloud computing and database as a service. Next, we will see how the cloud computing and database as a service has been an irreversible development. Then, what types of configurations and orientations of cloud is available for adoption. So we will focus all through on database as a service. We should also see that how the cloud has benefited us so far, and where are the areas where we need to expect improvements. Now, wheresoever we are, and no matter whichever technology or platform we are using, we are always concerned about data security. So now today again we will not lag behind in this aspect. Finally, what is the roadmap on future developments and what we can expect on enhancements shall be our final area of discussion. Now, since the scope of this topic is wider, so I will not be touching on any particular solution available by a provider. Also, critically analyzing a particular solution over other will also be out of the scope of today's session. This is a knowledge sharing session, so I would like to schedule the QA portion or question and answer portion at the end so that I am able to complete the webinar in stipulated time, and then we will proceed for the QA session. Thank you. So moving on to the next slide, which gives us an introductory insight on DBaaS cloud computing. Do more with less is a popular phrase we have well heard, said oftenly in an IT organization. Now this actually transforms to improving resource utilization or resource pooling and enhancing flexibility. Cloud computing, which is already available in the market for a while now, has actually achieved this objective. There is a choice of adopting private cloud or a public cloud or a hybrid configuration. So we'll talk about the cloud model or the deployment model a little later in this webinar. So we shall see how and why we choose a particular cloud model or orientation. Many IT companies, due to a host of reasons, have a multitude of independent servers and databases. Sometimes this number is really very high. So over the time, enterprises have realized the potential of virtualization and integration, which increases resource utilization and provides flexibility and quickly establishes standardization. So cloud computing is thus a natural development. As the next steps, one also tends to adopt the solution which helps to automate these activities of integration, especially the applications and databases. So we will see how it's achieved in the next few slides. In cloud computing, we all know about infrastructure as a service, that is IaaS, software as a service, that is SaaS, Similarly, database as a service, which is sometimes abbreviated as DBaaS, is emerging and growing and getting popular among cloud providers. Databases are the base of many enterprise applications. So historically, these databases, even though belonging to the same organization, and multitudes of those reside on independent machines, each project tends to acquire its own hardware and software and hosting environments. Modern databases like DB2, Oracle, SQL have advanced features and options so that they can be used to provide a larger shared service to the enterprise as a whole. This really helps to allow various applications to talk to a single database. The options are available in a DB software, which enables them to run on advanced servers, on clusters, and then they can incarnate themselves into multiple parallel instances. These features also enable them to allocate requisite processing power to the applications connecting them or application schemas residing under them. So by adopting this path, companies can acquire a number of benefits like higher availability, cost savings, better service through centralized management, and then reduce risks. So as we see here in this slide, that base of DBaaS originates from the fact that in many enterprises, each application development team architects build and deploy each of the individual technologies that make up the application. The underlying databases are not only unique to the application, but reside on different platforms, and even the technology is different. A large enterprise may have thousands of individual databases, instances running on a variety of hardware, each configured separately and managed independently. Now, if this is going to be replaced to a centralized singular platform, and just imagine the complexity we tend to reduce by doing so. However, I must say that we do realize that it's simpler said than done. But what is it that makes this achievable? One good feature usually applicable to many application development today is the seamless connectivity to database. Application programs are often transparent to the databases and independent of whosoever database technology we choose. They are also independent of hardware platform or OS we use. So we shall see how this again benefits us in DBaaS or cloud computing. Now we talked about the immense capabilities of a DB software. A single DB can support an enterprise shared service. It can cater to a multitude of applications. So of course we all know that we can create a separate schema or schemas unique to the application. And we can configure parallel instances for a singular database, and parallel computing capabilities can be exploited of the hardware clusters. We are also aware that how we can add CPU or memory resources on demand. Well, it is lastly bidirectionally. So tomorrow, if you want to decommission one of your large DB, you may also like to say goodbye to the extra CPU or memory power, which is releasable now. Isn't it interesting? So how is it achieved? We will discuss this shortly. As we can very well anticipate, we do need extra and skilled human resource, and in our case DBAs and administrators and architects to support our object. We can already foresee that such type of achievements require a considerable skill, as there could be a lot of requirement of DB migrations or applications and so on. There's also need of good understanding of the application architecture and design itself. DBaaS service can be hosted with the help of providers and set of tools. So naturally we have to analyze this requirement extremely carefully, as one basic requirement is naturally a very high uptime. This requirement is extremely critical, and as anybody who might have guessed, it is going to be a shared service which will cater to a host of applications and applications underlying data. There are tools and list of providers who help companies in configuring and adopting database service. So one important feature one might like to look into is the level of self-service and automation offered by the provider for obvious reasons. So the benefits of cloud, especially DB cloud computing, are just not limited to integration and resource pooling. When we have a shared DB service up and running on a cloud and supporting enterprise application, you have other advantages as well. For instance, the architecture delivers a number of benefits like higher availability. So all applications in Purview immediately benefit from automatic failover. This is an implicit benefit of cloud computing and something which is automatically available. Thus it can lower your cost, as all applications get it by virtue of being on cloud. So no need to explicitly invest on HA. So as we saw, that cost saving, as we already saw earlier, is also driven from pooling hardware resources together and driving up efficiency. The overall cost to the business should be reduced. As an extrapolation, more the individual database servers being used, more is the savings. In fact, we have been doing this for modern databases by allowing the use of many smaller servers in a cluster configuration rather than a few large servers. So we have the software savings by the consolidation of database software licenses, and it's always a better service through centralized management. By centralizing the overall management, we can have enterprise standards in place faster and precise. Administration and management can be handled by full-time experts rather than part-time resources that are responsible for other tasks, or short-term hires who tend to become idle when project finishes and factors increase in attrition. And other related benefits are reduced risk. The whole environment is managed and support is available on request. So in the decentralized model, support is often performed in a piecemeal, ad hoc or project basis. For instance, once the UAT or pre-production activities are finished, the resource may or may not be available, as for the production tasks, different teams take over. So what if the enterprise is expecting another set of major enhancements, say 1 year down the line? Other major benefit is that since all the advanced features are available on demand, there is no lead time for acquiring, configuring, and testing the advanced option. The option is already tested and available. It's just that one requests and merely starts using. In modern cloud computing environments, you just choose the option, help yourself with the self-service, and you are just charged back for the amount or the duration of services used. So it's like pay per usage. Now, for instance, you hit into some particular one-time data requirements to be stored on a tape. Just help yourself without now worrying to get expensive tape drives, then configuring it, and then dumping it for the rest of your life to chunk at a corner space. And how many times we did experience a similar situation. So here's an interesting diagram on the components of a typical cloud. We have grid management, backup and recovery, clustering software. We have a database. We have storage management. Of course, we have OS and servers. We have a disaster management plan. We have storage area networks. So basically, this is something which is called an architecture under cloud computing. And so far we talked about the end user benefits leaved out of cloud computing. But what of the vendors? What or how the provider should think of providing, augmenting, or enhancing the service? Earlier we already saw the architecture some of the providers have. In the configuration features, provider has an identity module wherein a user must be accurately identified and provide all the access related to his role. Not only the user or user group activities are private, but it also is important to restrict the user strictly to his role and privileges. Another essential aspect of cloud computing is open client, and now this is very important. It signifies that access to the cloud service must not oblige the user to use a particular technology only. Users may or may not look for another cloud vendor to provide for his cloud requirements down the line. This can only be achieved by adherence to open client standards in the state of cloud computing. Now, related to the requirement of identity is most vital requirement in cloud computing today, which is being critically assessed by a prospective cloud client. We will discuss this on more detail when we discuss on the deployment model of cloud. This public cloud needs much well-addressed security features, and it may be required on a private cloud deployment model. Cloud vendors must be very clear on the SLAs. The shared service downtime can spell havoc for an enterprise, and it's unthinkable. So what SLAs are guaranteed and must be guaranteed are to be done in no unambiguous terms. The relationship between the cloud provider and the user is spelled on SLA, or service level agreement. SLA is really the foundation of the consumer's trust on the provider. SLA must contain service level objectives that define measurable conditions for the service. The consumer always weighs the terms of SLA and the SLOs, that is service level objects, against the goals of their business. This SLA, which is very important also, contains these things like set of services that provider will deliver, complete specific definition of each service, responsibilities of the provider and the consumer, and set of metrics to determine whether the provider is delivering the service as promised. Then there should be an auditing mechanism to monitor the service. The remedies available to the consumer and provider if terms of the SLA are not met. and how the SLA will be changed over the time. Then we have something called as location awareness. It's a way of identifying the location of the physical machine hosting the cloud infrastructure. And we will especially see the difference when we talk about the private cloud. So it's an absolute requirement for many regulations and governance as well. For instance, sometimes there may be a legal restriction for a company as to where the servers are physically present, although the cloud computing itself is based on the norms of location independence. Then we have metering and monitoring. So all cloud services must be monitored for cost control, chargebacks, and provisioning. Management also requires metering to determine who uses the services and to what extent, provisioning to determine how resources are allocated to consumers, and monitoring to track the status of the system and its resources. So briefly I will discuss about the cloud classification. Public cloud in simple terms is characterized as being available to clients from a third-party service provider via the internet. The term public does not always mean free, even though it can be free or fairly inexpensive to use. So a public cloud does not mean that the user's data is publicly visible. Public cloud vendors typically provide an access control mechanism for the users. Then it provides an elastic, cost-effective means to deploy solutions. And private cloud offers many of the benefits of a public cloud computing environment, such as being elastic and service-based. Difference between private and public cloud is that in private cloud-based service, data and processes are managed within the organization without a restriction of network bandwidth, security exposures, and legal requirements that using public cloud services might entail. Private cloud services offer provider and the user greater control of the cloud infrastructure, improving security and resiliency, because user access and the networks used are restricted and designated. We have something called community cloud, which is controlled and used by a group of organizations that have shared interests, such as specific security requirements for a common mission. The members of the community share access to the data and applications in the cloud. We have another classification called hybrid cloud, which is a combination of a public and a private cloud that interoperates. So let's now understand the terms like elasticity, interoperability, and other characteristics of cloud computing. Overall, we are focusing on database as a service, although some are general concepts applicable to all services. Elasticity, as we already talked about, is the ability to scale resources both up and down as needed. To the consumer, the cloud appears to be infinite, and the consumer as much as or as little as computing power as required. This characteristic is very important and at the heart of cloud computing. It determines the chargeability. Portability is the ability to run components or systems written for one environment to another. So in the world of cloud computing, this includes software and hardware environments, both physical and virtual. Earlier we discussed Open Client, which enables portability and interoperability, and these are very vital characteristics of cloud computing. Interoperability is concerned with the ability of systems to communicate. It requires that the communicated information is understood by the receiving system, and in the world of cloud computing, this means the ability to write code that works with more than one cloud provider simultaneously. regardless of the differences between the providers. Multi-tenancy is a property of multiple systems, applications, or data from different enterprises hosted on the same physical hardware. Multi-tenancy is common to most cloud-based systems. Then finally we have, I won't say finally, but we have another characteristic called measured service. In a measured service, aspects of the cloud service are controlled and monitored by the cloud provider. This is very crucial for billing, access control, resource optimization, capacity planning, and so on. Then we have very important characteristic called on-demand self-service. It means that a consumer can use cloud services as needed without any human intervention with the cloud provider. This self-service is a great feature, and we already touched upon this earlier as well. Now we have some other characteristics like cloud bursting, which is a technique used by hybrid clouds to provide additional resources to provide to private clouds. And then we have governance, which refers to the controls and processes that make sure policies are enforced. Moving on to the next slide. Now, good governance is a key enabler for cloud computing. There are certain ITIL-based processes defined for cloud computing as well. Like we have service portfolio catalog, provides a clear understanding of the cloud services that we have demand management, we have information security management, which provides data security and privacy, it allows customers to see only their data. We have availability management, we have change management, which change management provides a way to ensure that change is implemented in a controlled manner. And we have the tools which records these parameters or processes as well. We have other ITIL processes like release and deployment management, and in relation to cloud services, mean that provide a mechanism which enable clients to effectively utilize the services. Then we have access management, we have service asset and configuration management, and we have event, incident, problem management. So all these are key enablers for cloud computing. Now, database as a service should deliver capabilities spanning the entire database cloud lifecycle. It should let cloud administrators identify pool resources, configure role-based access, define the service catalog and related chargeback plans. It should allow cloud users to request database services and consume them on demand. This allows the users to scale up and scale down their platforms to adapt to changes in workload. And then it also lets both parties to understand the cost of the service delivered and establish accountability for consumption of resources. The key benefit of a database cloud is to enable faster deployment of typical platforms by moving away from admin-driven provisioning to end-user-driven provisioning. It allows administrators or DBAs to pool resources, to standardize and automate deployment processes, establish templates to service catalog, and set up role-based access and privileges, and so on and so forth. They can even set quotas to limit overconsumption and establish policies for scaling up and scaling down, establish policies for decommissioning a resource, and then enabling metering and optional chargeback on consumed resources. So this was with reference to deployment, and as we said, that self-service is very, very vital to cloud computing and acceptability to the clients. Cloud management, we have a database as a service packs provided by the vendors, which is sort of an out-of-the-box self-service portal usually. Cloud users can be presented with a GUI or graphical user interface to provision database services without the need of intervention from provider or minimal support of the provider. This is really a great feature. Self-service portal must enable cloud users to monitor resource allocation, request and provision database services, monitor performance of provision databases, then control availability of provision databases through just simple startup and shutdown, push buttons. And then we can have push buttons to decommission a database service itself. Again, we also see that self-service portal allows administrators to configure the cloud and define policies for the cloud, expose it to certain users, and decide the total amount of resources each user can reserve, and so on. Users can log into the SSP and provision the database they require. The user can even define the time when the database will be decommissioned automatically. So just see how much versatile these SSPs are. So before the SSP can be used, the user privileges, user quotas, roles for zonal access, and chargeback mechanism can also be defined. Then privilege delegation allows a login user to perform an activity with the privileges of another user. This is also a good feature. Then we have sudo and power broker. These are privilege delegation tools which is directly available at SSP for self-service. Then allows a login user to be assigned to these privileges. So typically the privileges that are granted to a specific user are administered centrally. For example, the sudo command can be used to run a script that requires root access. Then we have a power broker. So these facilities and features are available at SSP. Coming to the service configuration and management, where typically one can start the configuration by just clicking Setup Cloud Database. So these are the standard packs available where you can start configuring your service. Then a database zone we have referred to here is just a collection of servers or clusters with pre-installed database software. Each server in a database zone has identical platforms and database versions. For servers that support multiple database versions, a separate database zone must be created for each database version. So in the create new database zone, we can enter a name and description for the zone and specify appropriate values for placement policy constraints based on the resources that are available to the members. Placement policy values are used during deployment to filter out hosts that are overburdened. one can really specify maximum CPU utilization, which is the average CPU utilization percentage over a specified period. Then maximum memory allocation, that is the average memory allocation over a specified period. Maximum number of database instances. So we can also limit the resources being used by the user. Then of course we can limit by quotas. Quota is the aggregate amount of resources that can be granted to each self-service user belonging to a certain role. So quotas can again be based on total allocated memory that can be assigned, or total allocated storage that can be assigned, and the number of databases. So this was about CPU allocation, and of course we can do the storage allocation as well and specify the DB character set. Then we need to understand in database as a service cloud computing a term which is called service template. The service template is nothing but a standardized service definition that can be used by self-service users. One can create service templates that can be used to provision databases in a set of selected zones. Here also we can provide the database version to be used and log down the values. We can also specify the number of parallel instances for the databases. We can define and select database template which contains the database configuration information. So the template helps to quickly deploy the databases across enterprises. We can specify the database credentials, the storage types and amount also can be specified. These are the elastic parameters. Similarly, specific to the storage locations, as I already discussed, that file locations and locations for the logs for easy accessibility, of course, can also be specified. Now, talking about the file location or the log location, those can be selected from the available values only. So, as we are talking about cloud computing environment. And as we already said that other parameters like character set, block sizes, processes, and other configuration parameters, connection modes, and so on can also be specified. And of course, these parameters are elastic or dynamic in nature. Now, the self-service features, which is very vital to the cloud computing environment, allows you to create as many service templates as required. Maybe one each for small, medium, or large databases. So you can have a different service template for a small database, a different one for a large database, and deploy the database accordingly. Service templates can be made available to a restricted set of via specifying the roles. So you have a service template, then you specify a specific role. Now, most important aspects in cloud computing is the chargeback, because remember we are paying for the services which we used and the amount of the time or duration which we used. So chargeback, as the name implies, is the tool of accountability. The applications primarily use can be generated, can be generally sorry. So in Chargeback, we do provide resource usage metering by aggregating and normalizing the enormous amount of metric data Enterprise Manager collects. Then we can provide IT a means to charge an amount to internal organizations that use resources. We can provide internal organizations and users with reports detailing their consumption and charges. Now, Chargeback has three universal metrics against which to compute resource consumption. We have CPU usage, we have memory usage, and storage allocation. So these are the primary parameters where the Chargeback is calculated and built. So these three comprises a universal charge plan that can be applied to any target type signed up for Chargeback services. So given the variety of processor architecture, the universal plan can build different rates as well based on the CPU model. So of course, the advanced CPU you are using, you will have a better or most costlier charge plan. So in addition, we can also have extended charge plans that apply target specific charges. Extended charge plans provide flexibility in how you will bill for the services, allowing you to override or adjust universal plan rates and establish different rates based on target configuration or charge flat and usage-based rates. So various chargeback plans are offered by the vendors, and you really need to see which chargeback plan suits you the best. Now coming to the cloud computing and privacy. So with the recent shift in computing architecture from dedicated servers in the data center to virtualization and cloud computing, we need to rethink our IT security methodologies. And while we focus on database security, different approach works for enabling privacy to a user group. More and more applications are collapsing into virtual machines, and in the case of cloud computing outside the enterprise parameter, it undermines the past assumptions that led to appliance-based security deployments. Even more challenging from a security perspective, these new databases may dynamically appear in new locations over the course of time based on organizations' changing capacity requirements. We have already discussed about open client on cloud environment. So the best way to secure databases on virtual machines or cloud environments without sacrificing the huge benefits of these new architecture is to use software-based solutions that share the elasticity of virtual machines and cloud computing. The challenge is creating host-based solutions that do not suffer the same drawbacks that made old host-based solutions irrelevant, namely, to name a few, intrusive implementation, performance issues, and the need to quickly adapt to new and changing environments, new operating system versions, new application versions, and so on. So the solutions have to be the lightweight and use software that can be easily added to the virtual machines where needed, and be installed in parallel to the first database that is installed on a machine. This means that adding a layer of security does not require changes in the architecture and does not rely on the virtualization technology in use. Virtual machines, as we know, running our databases are provisioned and deprovisioned to balance capacity needs. So no manual intervention is required at the management console. So here is a very good depiction about implementing security. So this is, as I discussed, is a host-based solution. We have few sensors in place to detect any intrusion, and this is the firewall, and this place is for the enterprise. This is under cloud. This firewall may be already there with the enterprise, and main security provisioning is done by the sensors, and this is a software-based, host-based solution. Security SLA is provided by the vendor and needs to be critically analyzed in line with the company policies. So when the decision is such to adopt the public cloud deployment, there is not much control on who accesses the data or what type of firewalls is to be provided. So naturally, many solutions are available to encrypt and store the data, and similarly the databases have the capabilities that queries can be done seamlessly on the encrypted data without noticeable performance issues. So security aspects at a private cloud are going to be different compared to the public cloud. As we can see, that network security approach may not require a change, although we need to know that where the private cloud is going to be hosted. Then one aspect in private cloud security is that it crosses enterprise departmental boundaries. One departmental data, for instance, data of payroll, accounting, and finance may be confidential, and sharing the same platform. Security needs to be devised to prevent an unauthorized access. And some companies feel safer with the hybridized approach. So naturally, security features provided must be thoroughly rechecked, and more often than not, hybrid cloud implementations need to club all the features of security strategies as they cater to public and private cloud implementations. So we see that the advantages are really overwhelming and possibilities are immense. Just imagine when you can have your dev, QA, and UAT, some environment ready and refreshed in a flash from the production environment. And you can use your extra environment as per your typical requirement. So you need not to go for every requirement which may be required down the line right from the beginning. And also you may decommission your extra resources or databases if not required. So you have to pay per the usage. We also discussed the self-service capabilities, automation in commissioning or decommissioning a resource or a DB and so on. So these are very interesting and excellent features cloud computing environments provide today. And we have the best part, which is optimizing your application by adding a resource, harness more CPU power or memory, or detach the extra resource if no longer required. So you have the value for money. If one is not having a development environment for the production, you can just create the development environment without really going for the extra hardware resources, do the testing and decommission the development environments. So the database as a service provides a splendid breakthrough, and adopting a private cloud really provides a good choice as of today. However, it's not as simple as it may appear. Tremendous support from DBAs and the technical staff would really be required in the transition. Then thorough knowledge of internal workings are the must for migrations and implementing or carrying forward the best practices. So these are really vital for your implementation to support the decision of the company to go for cloud computing. And if you recall, in the beginning of this webinar, we talked about the mandate of doing more with less. Thus, we see how the cloud providers provides us a platform and a service to achieve this object. So we also talk about the SLAs and how the vendors provide the near 100% uptime. We saw the advantages of HA and failover implicitly available to all applications under cloud ambience. And we also noticed how the enterprise gets a robust, low-cost solution in the long run and value for their money. Thus, we can say that we have a reliable solution in place. We have better uptimes, splendidly managed environments, and seldom SLA breaches. But there is one area of concern in the current state of cloud technology, which is planned downtime. We all know that we have two types of outages: planned outage, which we have fixed to carry some sort of maintenance or patching or release deployment or software upgrade. Unplanned is the one which arises out of a sudden problem or a bug or a crash. While we can reduce and proactively control an unplanned outage, planned outage in a cloud environment is really scary and must be planned well. An application or database upgrade required by one application may seriously impact other applications which do not require such upgrade. However, modern databases and cloud solutions can circumvent the situation. But this is one area which needs improvement and enhancement, and maybe it's on the cards on future roadmap for cloud development. Then we have excellent backup strategies in place, and we have better mean times to recover. We can have a point-in-time recovery as well, depending on the backup strategy. Touching on some internals of cloud computing, where providers depend usually on checkpointing techniques to ensure reliability and adherence to the SLAs. It is a way whereby the cloud technology assesses its own functioning and performance and self-tunes for optimization. So these are a few internal algorithms which a provider uses to provide good reliance on cloud technology. Elasticity of resource usage is other aspect, extremely reliable. A few key areas we have already discussed as a scope for future development. We already spoke about planned outage. So other areas which the provider can look forward is the increase in security provisioning in public and hybrid cloud deployment models. So the vendor should be able to provide more assurance and confidence in those areas or those environments as well. Now, OLTP environments require a complete sales assurance and zero data loss. OLTP databases on public cloud still pose a challenge for the providers and concern to meet their SLAs. So we can expect more improvements in these areas in coming times. So this was all about the cloud computing on database as a service I had for today. So I would really like to move to the question and answer session now.
All right, thanks for the insightful presentation, Mr. Om Prakash. Let's quickly take up the questions now. Please read out the questions and the answers so that all our users may listen to the commendable insights. You have the questions in your questions pane. Please start with the first question.
One moment.
Sure.
One second. Let me locate that.
Yeah, sure.
So there's first question from Ajay Joshi, who asked that DBaaS, is this concept implemented and used in India? If yes, any examples? In India, it's very well used, I would say, and there are different deployment models also available for the usage of database as a service. And as I talked about, there is infrastructure as a platform as a service, which is being already used in India, and India is one of the foremost countries which have used these services as well, and there are many examples of these services provided by the leading vendors today. Coming to the next question by Guru Swami. For example, if DBaaS vendor provides this service in data center A and my SS vendor application is in data center B, will my data transmission usage cost be high? It all depends on the services provided and the chargeback plan. I already discussed about the chargeback plan, so you need to really understand the chargeback plan by the vendor and see what will be the charges. And I believe that you are using a different vendor because of certain capabilities offered by the provider. So if it's a necessity that your database as a service is going to a different vendor compared to your SaaS, then you have to really look at the chargeback plan and the amount of data which you might be having. Otherwise, you can as well go for the same vendor as well. Now, again, the next question from Guru Swami, will the DBaaS vendor provide? Oh, that's, I mean, you have to have some knowledge about cloud computing. So it depends on the vendor. I really cannot say that whether a vendor will provide IaaS or PaaS. Some vendors do provide, IBM provides, Oracle provides PaaS and IaaS and all those stuff. Ashish Vets asked another question, how we can control security in DB as a cloud? There can be clients who don't want to share. So we talked about a lot and in detail about the database security. Different security standards apply whether you are using a private cloud or a public cloud. In private cloud, I discussed there are interdepartmental security concerns. So you can use data encryption. You may like to again review the webinar, and I think question will be self-answered. Then we have another question from Sridhar. How is the performance of the database measured? Okay, this really is not a parameter of discussion for database as a services. Database as a services has a lot more and versatile usage and offerings. Database performance is one of the parameter, and really database performance can be much improved if you are going for database as a service. It's just you need to know that what type of services you are hiring. The next question from Nimit Saxena is, how safe is it for an organization to use a public cloud? That is putting the production data. This is something which we need to assess, and as I told in one of the last slides, that you may expect some more security provisioning for the cloud computing. Databases on the cloud can be of concern as of today, and some of the compliances for the companies may not allow you to go for a cloud computing straight away. And even if a company is going for a private cloud, they need to really see where the location of the data or the servers would be, and whether they are really legally compliant, as the data is a very important resource for a company or an organization. Next question is from Gagan Maheshwari. In Chargeback, what is the difference between memory and storage usage? Does this refer to RAM? Memory usage, this is a very simple terms, that memory is something your memory of your server, and storage is something like your hard disk space or your storage areas, area networks, or the secondary storage which you are using. So both the terms are different, and since these parameters are really elastic, so you can really have extra resources, extra memory, extra secondary storage, or extra hard disk space, or decommission the extra unused space, and you'll be charged on exactly the resource you are using. Ramesh Rajamani asked one question. In the cloud security diagram, I saw the sensors connected to the client. So how is that works with the security? Okay, see, since this is a knowledge sharing session only, so I have taken some portion from one of the best providers. Like I have taken some sources from IBM, from Oracle side, or from Symantec, from McAfee. So in the diagram, it shows that there are 3 sensors. Now, as I talked about the security features, I said that we can the security for private or public cloud would be really different from the security as provided conventionally. For the cloud is something like a software-based solution or a host-based solution. So the software-based solution or host-based solution, they have a different modules or different components which they call sensors, and the sensors really see any intrusion of any, checks any intrusion, I would say. Pradamya Patil asked question that what is a DB zone, and I think I discussed DB zone in great detail. When you are using a service pack or self-service portal pack to configuring your database as a service, you start with configuring database zone, then you go and configure database templates, and then provision for the databases. You configure the roles. So there's something called, it provides you a template whereby you can really deploy a database by using that template. Next question from Pradimya is, Usually if there is an issue with the database server, it will affect all the applications talking to the databases. Similarly, in case of DBaS, if any one application perform some malicious operations which hangs the DB server, will it not affect other consumers also? How does it separate? How does it separate? Now there are certain SLAs. It's not, I mean, the technology is not that simple as we are referring to here. We have so many advancements in the technology. We have parallel servers, we have failover servers, we have flashback. So I'm sure that even if some operation is done by an application which really hangs something, so it can be, we can really go to the previous state very fast, or we can go to the, or switch over to the failover server, or maybe there is no impact at all because we have so many parallel instances available unless and until you cache your database, and that's actually very difficult to do in today's environment. We are talking about cloud computing, which are so robust technologies as compared to the single server implementation. That I don't say that it's not at all impossible, but the possibility will be really very remote. Now, Guru Swami asked us that what is automatic failover? Automatic failover, as just now I discussed, that if machine A is experiencing some problem, so the services are configured in a manner that it will seamlessly go to machine B without interrupting most of the clients or most of the users connected to the service. So that is something which is called automatic failover. That is seamless or transparent to the application user. Kishore asked us that what is the difference between OS cluster and rack system. That is something which you can already look at into some of the sites. You can look at IBM or some Oracle sites to refer to what exactly is OS cluster. Rack is something which is termed with reference to Oracle, and OS cluster, so many OS clustering solutions are available as a hardware in conjunction with the operating system. So more than, I would say more than one servers are clustered together to provide you parallel computing power. What is the role of DBA in cloud computing? I would say that the role of DBA is extremely vital, and I have referred to many times in my webinar. DBA will be a very critical resource for the transitioning from a conventional system to the cloud computing environment. So he will be really vital for database migrations or applications or all that stuff. Okay. Shri Nada Reddy Jyoti asks one basic question, that what is the basic difference between SaaS and cloud model? Okay, I would say that there won't be any comparison between the two, because SaaS is a service and cloud model is a deployment model. SaaS is nothing but software as a service, and we have 3 to 4 cloud models available, like private cloud or public cloud. Then Sarada asked that what is the procedure for working on cloud computing. That maybe you can again refer to this webinar. There are various providers available for offering the services cloud computing, and they also refer to in detail how to establish a cloud for your company. Then I believe the next question is, will there be different accounts for stage, beta, development, production environment? Okay, I think this question may be rephrased because I'm not very clear about what the question is, but I believe he's asking about whether there will be certain staging or some environments he's referring to for deployment. So usually, as I discussed, that one way is that you have a self-service portal, or you have database patterns whereby you can really deploy. And if you're talking about some new version in cloud, in database as a service provider, then of course you might be having certain beta environments before you environments, or if you're referring to some stage or some development environments. So actually this question can be rephrased and or maybe given to the moderator, who can redirect this question to me again. So I think I'm done with almost all the questions. And if anybody has any more questions, those can always be redirected to me at any time.
All right. Thanks, Mr. Om Prakash, for your session on database as a service, cloud computing. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all.